Imagine stepping onto a train in downtown Paris and arriving in Berlin so quickly that flying no longer feels like the fastest option. No endless security lines. No waiting at the gate. No long taxi to the runway. Just a smooth ride at nearly 500 kilometers per hour across the heart of Europe. It sounds like something from the future, but that future is already taking shape. Europe is investing in a new generation of high-speed rail that could completely change the way millions of people travel. And if this technology reaches its full potential, short-haul flights may never be the same again. Welcome to Future Tech Drive, where we explore the world's most advanced transportation, groundbreaking engineering, and the technologies shaping tomorrow. For decades, airplanes dominated travel between European cities. They were fast, convenient, and connected countries like never before. High-speed trains offered an excellent alternative, but most people believed they had already reached their limit. Engineers often argued that steel wheels on steel rails could only go so fast before physics took over. But history has shown that every technological limit is simply a challenge waiting to be solved. Europe's high-speed rail story began with a simple goal: move more people, more efficiently. As cities expanded and airports became increasingly crowded, governments realized they needed another solution. Instead of building endless highways and larger airports, they invested in dedicated rail networks, designed specifically for speed. The results were remarkable. France introduced the TGV, Germany expanded its ICE network, and Spain built one of the largest high-speed rail systems in the world. These trains didn't just reduce travel times. They changed the way people lived, worked, and connected across the continent. Now Europe is preparing for the next leap forward. Reaching speeds close to 500 kilometers per hour isn't simply a matter of installing larger electric motors. Every increase in speed creates new engineering challenges. Air resistance grows dramatically. Vibrations become stronger. Even tiny imperfections in the track can affect stability. That's why modern high-speed trains are designed as complete engineering systems rather than faster versions of older models. Their long, streamlined noses slice through the air with minimal resistance. Lightweight aluminum and advanced composite materials reduce weight while maintaining incredible strength. Smooth underbodies guide airflow beneath the train, reducing turbulence and improving efficiency. These improvements allow trains to travel faster while consuming less energy, proving that smarter engineering often matters more than raw power. But one of the most important innovations is something passengers rarely notice. Mounted above every electric train is a device called the pantograph. Its job is to collect electricity from overhead power lines while the train moves at extraordinary speeds. At nearly 500 kilometers per hour, maintaining perfect contact with those wires becomes incredibly difficult. Even the slightest interruption can reduce efficiency or damage equipment. European engineers completely redesigned the system. Modern pantographs use aerodynamic shapes, advanced suspension technology, and intelligent control systems that constantly adjust pressure against the overhead wire. At the same time, stronger electrical infrastructure delivers a stable flow of power, allowing trains to maintain incredible speeds with remarkable reliability. While these mechanical breakthroughs are impressive, the real revolution is happening inside the train's computers. Thousands of sensors monitor everything from wheel temperatures and suspension movement to wind conditions and electrical performance. Every second, onboard computers analyze this information and make tiny adjustments that improve safety, comfort, and efficiency. Artificial intelligence is taking this even further by predicting maintenance before problems occur, optimizing energy consumption, and helping operators respond instantly to changing conditions. Thanks to these innovations, Europe is proving that the old limits of high-speed rail are disappearing. But even if engineers succeed in building trains capable of nearly 500 kilometers per hour, one question remains. Can they actually compete with airplanes in the real world? The answer might surprise you. Most people assume airplanes are always faster because they travel at nearly 900 kilometers per hour. But that's only part of the journey. Think about everything that happens before a plane even leaves the ground. You travel to an airport that's often far from the city center. You check in, pass through security, wait at the gate, board the aircraft, taxi to the runway, and only then does the flight begin. After landing, the process happens all over again before you finally reach your destination. High-speed rail removes many of those delays. Most railway stations are located in the center of major cities, allowing passengers to arrive just minutes before departure. There are fewer checkpoints, faster boarding, and no waiting for luggage after arrival. When you calculate the entire journey from city center to city center, high-speed rail can be just as competitive as flying and in many cases, even more convenient. That's why Europe isn't simply building faster trains. It's building a smarter transportation network. Imagine living in one country while working in another because your daily commute takes less than an hour. Imagine tourists visiting multiple cities in a single trip without ever entering an airport. Imagine businesses connecting major economic centers with reliable, comfortable, and energy-efficient transportation. This is the future Europe is investing in. The environmental benefits are equally important. As more electricity comes from renewable sources, high-speed rail becomes one of the cleanest ways to move millions of passengers. Fewer short-haul flights could mean lower emissions, less airport congestion, and a transportation system that's both faster and more sustainable. And the innovation doesn't stop here. Engineers are already exploring even more advanced technologies. Artificial intelligence will continue improving traffic management and predictive maintenance. Digital twins virtual models of entire rail networks will help optimize operations before problems even occur. Researchers are also developing magnetic levitation systems and other next-generation concepts that could push transportation beyond today's limits. Whether those ideas become everyday reality or not, one thing is already clear. The race toward the future isn't just happening on highways with electric cars or in the skies with next-generation aircraft. It's happening on the rails beneath our feet. So, will Europe's 500 km/h rail revolution completely replace short-haul flights? Probably not. Airplanes will always remain essential for longer distances and international travel. But for journeys between many of Europe's busiest cities, high-speed rail is becoming a faster, more convenient, and more sustainable choice. The real competition is no longer about which vehicle has the highest top speed. It's about which one gives people the best overall travel experience. And that's exactly where Europe's newest generation of high-speed trains could change everything. The future of transportation isn't arriving someday. It's already accelerating across Europe, powered by smarter engineering, cleaner energy, and technologies that continue to push the boundaries of what's possible. If you enjoyed this deep dive, don't forget to like this video, subscribe to Future Tech Drive, and turn on notifications so you never miss our next exploration into the world's most exciting transportation innovations. Now it's your turn. If you had the choice today, would you take a 500 km/h high-speed train or a short-haul flight? Tell us your answer in the comments below, and let us know what future transportation topic you'd like to see next. Thanks for watching, and remember, here at Future Tech Drive, we're always exploring the road, the rail, and the technologies driving us into tomorrow. See you in the next video.